Hello everyone, welcome to the Math Bender. I'm Adnan Zaidi, and in this section we'll discuss transformation related questions about functions. I already had uploaded a lecture on this topic. In this session I'll only discuss the questions related to it, past paper questions more precisely. So this is A-level mathematics. So the questions related to it are in the past papers as well. Let's start. So a function is defined by this, and a sequence of transformations is applied to the following order. So stretch to the x-axis with a scale factor of 1 over 2. So the first step is f of x is equals to x squared minus 2x plus 5. So a stretch parallel to the x-axis with a scale factor of 1 over 2, which means f of 2x, because this will give a scale factor of 1 over 2. So instead of x, I replace it with 2x. So 2x squared minus 2 times, instead of x, 2x plus 5 gives you 4x squared minus 4x plus 5. Reflection in the y-axis. So reflection in the y-axis mean f of minus x. So this function will be negative. So if I could, although I could write it the other way as well, but yeah, f of negative 2x. So this will be now 4 times minus x. So instead of, I'm writing, just to avoid confusion, I'll write this as f of minus, because now I'm taking this as f of x. So minus 4 times minus x plus 5. This will become 4x squared, because that will become positive, plus 4x plus 5. Stretch parallel to the y-axis with a scale factor of 3. So which means 3 times f of x now, which is 4x squared plus 4x plus 5. This is going to be 12x squared plus 12x plus 15. If I want to be on the safe side, what I could do is, since this was originally f of x, this was f of 2x. If I want to name it differently, I can write that this is now, let's call it g of x, so that the confusion is not there. And after applying g of negative x, this is what I just did here, it turned out a new function which is h of x, and 3 times h of x. This was the last answer. Depends, it won't matter to the examiner as long as you are getting this answer correctly. Let's see some other questions. So f and g are both defined as the function that you could see express this f of x. So the best way to do it is comparing coefficient. So x squared minus 4x plus 9, x squared minus 2ax plus a squared plus b, x squared minus 4x plus 9. As you could see, negative 2a is equals to negative 4, and a is equals to 2. And a squared plus b is equals to 9. So 4, instead of a, I replace it with 2, plus b is equals to 9, and b is equals to 5. I can write this as x minus 2 whole squared plus 5. Now express g of x in the form. So if I take g of x first thing, and as you see that this is 2 has been taken common throughout. So g of x is equals to 2x squared plus 4x plus 12. Now if I take 2 common, it will become x squared plus 2x plus 6. Now you need to bring it into a completing square method, although you can take that as well, but 2 times x squared plus 2 times x times 1 plus 1 squared plus 5. 2 times, you can write this as x plus 1 whole squared plus 5. The value of c is 1 and d is 5. So express g of x in the form of k times f of x plus h. Now let's look at the question. First let me write that question. So f of x is equals to, this is what f of x is, and this is what g of x is. So I can see this here. You have to write down g of x in terms of f of x. So what operation would you perform on f of x that makes you get this one? So I need this. So what should be multiply it with? Now look at this part. If I add f of, I need a plus 1 inside and a minus 2 inside. So if I add plus 3, I will get x plus 3 instead of x minus 2 whole squared plus 5, and I get f of x plus 3 is going to be x plus 1 whole squared plus 5. Now next, what should I multiply it with to get? So I write 2 times f of x plus 3, so 2 times x plus 1 whole squared plus 5. So this, the value of k is 2 and h is positive 3. So what are the two transformations? So the first transformation was, I'll write with the same ink, so translating 3 units to left. The next one, stretch on y-axis with scale factor, as f means scale factor of 2. Alright, so y is equal to sine x and it is transformed to this function. So I'll write down, it's a 5 markers, so which means it requires a lot of detail. So first step, f of x is equals to sine x. Now next step, f of half x is equals to sine 1 over 2x. I will write stretch on x-axis with scale factor of 2. 1 over 2 means scale factor of 2. Now next step, f of 1 over 2x minus 30. So sine 1 over 2x minus 30. Translation, that's the right word. 30 degrees right. Next, we have 4 times f of 1 over 2x minus 30. So 4 times sine 1 over 2x minus 30, which gives you a stretch of 4 on y-axis, vertical stretch. So let's look at another question here. Now, the diagram shows the function, so we have to look for two transformations here only. Now, let's look for translation up and down first. So, looking at this coordinate and this coordinate. So, in order to reach from F to G, I will go 3 up and 6 left. So from here I get an idea that it's 3 up and 6 left. So let's write it down for a moment. Erasing. Now let's look for another one as well, somewhere here. This point is translating to this point, and if it is the same translation every time, is going to be applying on the on every point then. So 1 2 3 4 5 6 to the left and 1 down. Now see, there is a change here. So this says that it's 6 left, but it's 1 down. So which means, let's try to check for the last one. 1 2 3 4 5 6 to the left again and 3 down, which means that this and these are different, but left is common. So which means the graph is moving 6 units to the left. So I'll write translating 6 left. So f of x plus 6, first thing. Now next, erasing all the rest and then looking for now stretches. Now look for horizontal stretch at this line here, and is stretched to this line. So if I look at the horizontal stretch, then there is a stretch. This is 2 units, and this as well is 2 units, which means this is not stretching or horizontally. Let's say if it is applied on the other line, any other line as well. For this highlighting blue line, this is stretched on 2 units, and this as well is on 2 units. So which means there's no horizontal stretch. So let's look for vertical stretch, and probably our next transformation. So this is vertical of 2 units, and this is vertical of 4 units. Can I say that this is a multiple of 2? So can I say 2 times 2? That's how it is 4 vertically. Let's see if it is applied on the blue line as well. So this is a height of 4 units, and this is a height of 8 units. So which means 4 times 2. So there you go, you found your second transformation. So stretch vertical 2 units on y-axis. Although vertical is pretty much evident and clear, but still you may want to write y-axis instead. So yeah, so 2 units, and it will be 2 times f of x plus 6, which is going to be equals to g of x. So let's look at another question here. So we have to write down 2 transformations here as well. So first step, let's look for it moving downward. So from A to A prime, 2 down and 1 right. So let's write it down, 2 down and 1 right. So B should be happening the same, 2 down and 1 right. So 2 down and 2 right. 2 down is common and 2 right. For C, 2 down and 1, 2, 3 and 4 right. So which means one thing is common, the whole thing is moving 2 units downward, but right transition is not the same. So we say that translating 2 units down and f of x minus 2. Now look for stretch. We've checked out all the ups and downs. Now look for stretching. Now check for horizontal stretch. So this line and this line, comparing both of them. Now this line is taking one block on the horizontal and this line is taking 2 blocks on the horizontal. So I can see that the original graph is being stretched on the horizontal for 2 units. Let's look if it's the same case here as well. So now I can see that 2 units, and if I multiply it with 2 I get 4 units. So which means this was 1 times with 2 and this was 2 times with 2, which means it is a horizontal stretch. So now we've got our second transformation. So stretch of scale factor of 2 units on y-axis. You want to write that down? So 2 times f of x minus 2. This is how you do it. And that is it. So this is it for today. If you have any queries related to this and any other further questions, you may write in comments. Please do give me your feedback about how the lecture was. I hope I've conveyed myself clearly. So until my next lecture, take care. Bye bye.